Hi, thanks very much for choosing to watch my talk online. My name is Iaizzi. I'm a AAAS Science and Technology Policy Fellow placed at the U.S. Department of Energy. But this talk is based on my own research that is not related to this current placement. And it's also important, you'll note there is a little disclaimer here at the bottom of the screen. These views are all my own. I'm not here as a representative of the Department of Energy. So today I'm going to talk about Arianna Wright Rosenbluth, the woman behind the Metropolis Monte Carlo algorithm. And so I'll start this story for you the way it started for me, which is that I was attending a computational physics workshop when I was in grad school, and Lode Pollitt put this slide up on the screen. This is the canonical paper you cite when you are talking about Metropolis Monte Carlo methods. And so this paper has, wrong direction. This paper has 47,422 citations as of last night, or I guess technically now it's the night before last night. But, and there are two things I noticed right away. So first, Edward Teller is the last author. He's a famous or perhaps infamous physicist known as the father of the hydrogen bomb. And so I was like, oh, I didn't know that he was related to this work. And then the second thing I noticed is there are two women's names. I realized I should point with my cursor, not with my hands. Two women's names, Arianna Rosenbluth and Augusta Teller, on this paper, which is, in 1953, I would say quite unusual. And so I was curious what the story is here, but I think to back up first, we should talk about what does this paper do? And so this paper has a first sentence that I think all of us would envy being able to write. The purpose of this paper is to describe a general method suitable for fast electronic computing machines of calculating the properties of any substance, which may be considered as composed of interacting individual molecules. So that is a very broad claim, right? Calculating the properties of any substance and essentially as composed of interacting individual molecules isn't much of a step back from any substance. And so this is a really remarkable claim, and the paper, in fact, backs it up. And so what is this method used for? And so I would, rather than list off all the applications, the Metropolis algorithm is a rare physics algorithm that is left physics and is now widely used all across basically anywhere someone's doing computational science or data analysis, computer science. And so it's in finance, it's in economics, it's in election forecasting. And so here's just off the first page of the list of citations on Google Scholar, sorted by most recent. So this is of the top probably 20 most recent citations. I just picked these. So a review of an experimental evaluation of deep learning methods for MRI reconstruction. So there's a biomedical imaging paper. Machine learning of cloud types shows higher climate sensitivity and is associated with lower cloud biases. So here's climate change research, combined crop modeling with remote sensing data using particle filtering technique to produce real-time forecasts of winter wheat yields. So here's agricultural research. And finally, mass reparameterization for rapid parameter estimation of inspirational gravitational wave signals. So here's physics, but also a completely different discipline of physics. So that I think sort of captures what's going on here, which is this is a very broadly useful algorithm, certainly on any list of most important algorithms of all time. Probably not more important than fast Fourier transform, but it's certainly up there. So what is Monte Carlo? So the original form of Monte Carlo was invented in the 1930s and 40s as it's a numerical method that uses random numbers. It's the first of these so-called numerical experiments, which means that you're using a computer to do something really different from the way that you do math by hand. So it's not merely accelerating a by hand calculation. It's really doing something fundamentally different. And it was named for Stan Ulam's uncle, who apparently was very fond of going to Monte Carlo and gambling. So in its original form, it's actually a pretty specialized algorithm that's useful for solving problems that have some built-in probabilities. So for example, this algorithm was developed in large part during the Manhattan Project. You might have a certain rate per unit time of spontaneous fission and neutron generation, then you might have a neutron capture cross-section, for example. That's another probabilistic thing. And then you want to know what is the likelihood that this goes boom or no boom, right? And so that's the original format of Monte Carlo. And the innovation of the Metropolis algorithm, it really inverts this method. So instead of starting with the microscopic probabilities that govern how your system behaves, now you can solve any stat-mech problem because you can start with the final distribution. For physics, we are talking about the Boltzmann distribution almost always. And then you use synthetic transition probabilities, basically things you made up according to some mathematical rules. And that allows you to understand these equilibrium properties of that distribution that we're talking about. And so the real innovation here is now you can use this as a much more broadly useful algorithm. And so where did the name come from? It's a natural question. So first, we'll start with the apocryphal story, which is that the male co-authors came up with this idea at a cocktail party, and they put their wives on the list, on the author list, to reward them for enduring a boring technical conversation, which I think is almost so, it involves so much sexism and my stereotypes of what the 1950s were like, that it's kind of hilarious that you could fit those all into essentially a one-sentence story. There's no evidence that this is true at all, and who knows where this story comes from. It just have been someone's speculation at some point. But the facts are that Metropolis, who was the first author, he built the Maniac, which is the machine they were using, electronic computer, but he had no other intellectual involvement with the project. So by modern standards, he wouldn't even be on the author list. Probably it is fair enough that someone who built one of the first electronic computers would appear on the author list of this paper. Marshall and Arianna Rosenbluth developed the main concepts. Augusta Teller did some of the initial programming work. Edward Teller provided this ensemble averages insight, which for reasons of time, I'm not going to go into, but it's this idea that you don't have to do time averages of things. You can basically draw random samples. And Arianna wrote the first full computer implementation by herself on the Maniac one. And so that was a really remarkable achievement. Programming now or writing a Monte Carlo simulation is pretty easy, but at the time, programming the computer in general was very hard. It was not, I think it would have been predated Fortran, so there would have been some amount of knowing the physical arrangement of the machine besides just, like not even just punch cards. So the answer to the question we started with is that, as far as I can tell, the authors are alphabetical, and Metropolis was the first author, and someone else did not think any more about it than that and called it the Metropolis algorithm, and probably didn't think anything of it at the time. So who is Arianna Rosenbluth? So she was born in 1927 in Houston. She was sort of a girl genius. This is a phrase I've seen in places. That's not a phrase I'm adding. And she got her bachelor's of Rice when she was just 18 years old, from Rice, excuse me. She qualified for the Olympics for fencing 2 different times. Both times she was delayed by war or finances. She got her PhD from Harvard at only 21 years old with Van Vleck, future Nobel laureate. And she was an Atomic Energy Commission postdoc in California. So after that, so that's Atomic Energy Commission is the predecessor to the Department of Energy. And then she met and she married Marshall Rosenbluth. And with him, she moved to Los Alamos. They were programming the Maniac 1. They worked on the hydrogen bomb calculations. So all of the co-authors on that paper I mentioned before, that was their day job, was working on calculations for the hydrogen bomb. And then she also did this Monte Carlo work. And unfortunately, shortly after that, she left the field. So she, when she became pregnant with her first child, she left science and never worked professionally in science again, which is a real shame. And unfortunately, she passed away in December 2020. And so here we have a relatively recent picture of her. I'm very thankful for her family for sharing that with me. So I wanted to end this on a positive note, and unfortunately, it's a sincere positive note, which is that when I first began working on this, really, there was very little information in the public domain, and certainly in a way that was accessible to anyone other than a technical expert willing to really dig into one of Jim Gouvernatis's the papers from that workshop he organized, which are excellent, I should say. And so since then, she has a much more fleshed out Wikipedia page. There's a photo of her on there now. She was actually featured. There's a piece about her in this month's APS News, because it is March 6th is the anniversary of the release of this original algorithm. And then she was eulogized in the New York Times, which I think is, certainly the sort of legacy that she has earned. And it was very nice to see that she's getting this recognition that she deserves. And I think a factor here is that during her lifetime, she was not particularly so for many years, she was unaware that this is true for many of the authors. They had moved on and were doing other things. And they found out later, oh, this algorithm we wrote in this paper we wrote in 1953 is important. But certainly for her, it was a surprise to her to learn that she was a relatively famous person within this narrow field. And she was also not very interested in publicity for it. But since her passing, her children have been very much more active in telling her story, which I'm very grateful for. It's been very nice to learn from them about her. The other thing I wanted to highlight about this New York Times article is Arianna Rosenbluth dies at 93, pioneering figure in data science, which is when I saw the headline, I was shocked. I was like, oh, I would have described her that way. It is a very accurate way to describe her. And, as a computational physicist, I have my blinders on. I'm just thinking this is a person that invented this important algorithm that I use, not this is a person who's, perhaps for many people, their main interaction with it might be through data science. And so I just thought that was like an interesting note to end on. I was very grateful to participate in some of providing information for some of these articles. And so now I have some closing remarks. So ironically, if you're watching this recording, you already probably scanned this QR code at some point. But writing this history required physicists with technical expertise to understand the importance of the science. And I'm really so Jim Gouvernatis owes a lot of credit for this. He identified the importance of this algorithm, maybe not uniquely, but certainly took the initiative to record the history of it while the authors were still alive. It's not always trivial to see what the important developments are in a field of science. And I think it's important to recognize that this really was, it requires some technical knowledge to read the original papers and then understand why this is important. And so physicists, you need to be aware of this, that you can't just count on someone else, a historian, to do this work for you, right? Like we have to play a role here. And time is a factor. So when all the authors of that article are dead. And when I started working on this, Arianna was the only remaining living author. Jim Gouvernatis, when he organized a 50-year reunion or a 50-year anniversary of the publication of that paper. So he organized a workshop at Los Alamos, and he had people involved early on speak. He interviewed some of them. So he interviewed Arianna. He may have interviewed Nicholas Metropolis, and he had Marshall Rosenbluth come speak at that workshop, which was that, it's a very good source of information. You have his, Marshall Rosenbluth's personal recollections of the development of the algorithm. And he was at the time already sick with terminal cancer. So he died only months after this workshop. And so really, time is a factor. If you don't record the history, it may die with the people who have it in their head. And so another reminder, just, keep that in mind, that you want to sort of keep an eye out in the history of your field, and, maybe think about writing some things down in a way that is useful for someone in the future. And then finally, I have a question that I want to know the answer to, which is that all these authors of this 1953 paper, they all worked on the hydrogen bomb. Was this algorithm developed for some question on the hydrogen bomb, or is this just purely, an intellectual interest that they had besides that? And I don't know the answer to that. I have seen the titles of several of these classified reports. The titles are obviously unclassified if I've seen them. written by Arianna. And so she certainly was working on hydrogen burning, but those are still classified. So I can't see them. I can't see if, oh, it turns out one of these is basically the same thing as this paper, but, secret because it has to do with building the super, or perhaps they are unrelated. So if you know the answer to that, obviously I'd love to hear that. And if you are someone with clearance who is interested in this problem, you can, like I've been speaking with the archivist at Los Alamos National Lab occasionally, and his recommendation is essentially, if someone who has the clearance to review those can review them and answer this question, I assume subject to whatever appropriate controls there would be to make sure you're not telling me anything classified, then this question may itself be unclassified. I might be able to find out, and I think that would be a nice little way to close off this, not close this story, but certainly to like answer a big lingering question. And so with that said, thank you very much for listening. And if you please feel free to reach out to me if you have questions or especially information.